So now we're ready for the no cloning theorem. So what is the no cloning theorem? Well, it says you cannot take an unknown qubit and turn it into two copies of this unknown qubit. So this does not work. But what does this mean? Well, here we have an unknown qubit. We have a state space of dimension 2. Here we have a state space of dimension 4. You can't take a state space of dimension 2 and turn it into a state and do anything to put it in a state space of dimension 4. We need to start with a state space of dimension 4. So how do we do that? Well, psi 0. So we need another register which starts in some definite state. So we take our unknown qubit in, say, 1 qubit, and another qubit, which is in a definite state, and we'd like to turn it into two copies of the same qubit. And I want to say we can't do that. Well, we would need, this goes to that, and suppose we started this in another unknown state. It would have to go to phi phi. But of course it can't, because the no cloning theorem says that you can't do that. And this says, look at inner products. So unitary transformations preserve inner products. And I haven't proved that yet, but it's one line, and I'll do that after this thing. So inner products are preserved. So we need to take the inner product of these two, which is just psi phi 0, 0. And we need that to be equal to psi phi psi phi. If psi phi equals x, get, well, this is 1. X equals x squared, which only works if x is 0 or 1. So what does that say? Well, if we had two distinguishable states, we could clone them. But that's, no, if we have two distinguishable states, we can measure which of these two states they're in, and then we can make as many copies as we want. If we have two equal states, we can clone them. And if we, assuming we know what the state is, we can make as many copies of it as we want. But if we have two states which we don't know and which are, not orthogonal, then we cannot clone them. Okay. So why do unitary transformations preserve inner products? Recall U is unitary if and only if U dagger equals U inverse. So, phi psi get mapped by U to U phi U psi. And the inner product here is just, say, phi psi. And the inner product here, well, we take the we take this ket and find the equivalent bra. So we take the conjugate transpose, and when we do that, it's phi u dagger, and then this is u psi. But remember, u dagger u is equal to u inverse u equals I. So this is phi times the identity psi, which equals phi psi. So inner products are preserved by unitary transformations. So this calculation was correct.